Hi, I'm Miss Hearn. If you like this video, please give it a thumbs up. That will help other students to find the video. You can also subscribe to my channel, Miss Hearn Mathematics, for more math videos. Here's another example. It says, determine if the sequence a sub n equals natural log of n over n converges, right? So for it to converge, that just means that there is some finite number so that the limit as n goes to infinity of that sequence equals that number. The limit exists for some real number L. Okay, so the way that one way we can do this when we don't have, I don't know anything about natural log sequences or anything, we don't have any special rules for this, is to compare it to the limit as x goes to infinity of the natural log of x over x. If the limit exists for this function, then the limit exists for the sequence. So how would we find the limit as x goes to infinity of the natural log of x over x? If I tried to plug in right away, what form would I get? That's right, because we get infinity over infinity, right? So we're going to use L'Hopital's rule. So that's going to be the limit as x goes to infinity of 1 over x over 1, which is just the limit as x goes to infinity of 1 over x, which equals 0. Okay, so we know that the sequence natural log of n over n converges to 0. This arrow is saying converges to. So this would be the answer. Okay, determine if the sequence a sub n equals n plus 1 over n minus 1 to the n power converges. If it converges, find the limit. All right, so again, we're going to compare it to the limit as x goes to infinity of x plus 1 over x minus 1 to the x power. All right, so what indeterminate form are we going to get here? If I try to just close, it is to the infinity power, but it's not infinity to the infinity power. It's what to the infinity power? Okay, let me ask a different question. What if I just asked you to find the limit as x goes to infinity of x plus 1 over x minus 1? What would that be? 1, very good. Because you can just look at the highest degree terms, right? So that means that this inside part is going towards 1 while the exponent is going towards infinity. So this is actually a 1 to the infinity power indeterminate form. All right, so how can we deal with an exponential form that's indeterminate? I cannot immediately apply L'Hopital's rule, right? So what did we do with that? Can you describe a little bit for me how we deal with something like that? That's right. We want to take the natural log of both sides, but notice I don't have both sides yet, right? So what do? We said, okay, well, let's say that this limit exists. We'll call it L. Okay, then now we have two sides of the equation. We can take the natural log of both sides. So we could say that the natural log of L must be equal to the natural log of the limit as x goes to infinity of x plus 1 over x minus 1 to the x power. You remember doing that? And then what did we do next? Excellent. I'm so glad that you remembered that, Emilio. Yes, we're actually allowed to bring the natural log through the limit. And then yes, that's right, Max. We can bring the x to the front of the natural log. Okay, and then now what? You could, I was thinking that too, you could expand that, but I don't think we have to, because another alternative would be to, remember this guy is going towards 1, and the natural log of 1 is 0. So we have x going to infinity, and natural log of x plus 1 over x minus 1 is headed towards 0. So this is an infinity times 0 situation. And what do we do with that? Remember, we either want infinity times divided by infinity or 0 divided by 0. So how can I fix this so we have one of those two situations? Not yet. You can't use L'Hopital's rule until you have either infinity divided by infinity form or a 0 divided by 0 form. Right now we have an infinity times 0 form. But how can I rearrange this so that I have one of the two L'Hopital's rule forms? It's rewriting the multiplication by x as division by 1 over x, right? So what I mean by that is we'd have natural log of L equals limit as x goes to infinity of natural log of x plus 1 over x minus 1 over 1 over x. Yeah. Okay, so now we have a 0 over 0. This guy's going to 0 still, and 1 over x is also going to 0. So now we can use L'Hopital's rule. So we have natural log of L equals the limit as x goes to infinity of... Now, how do you take the derivative of natural log of x plus 1 over x minus 1? Using L'Hopital's rule. Let's go off to the side. I think it'll be easier. So I'm going to differentiate the natural log of x plus 1 over x minus 1 with respect to x. Okay, so the first thing is anytime you take the derivative of the natural log, you're just going to take the reciprocal, right? 1 over. So that's going to be 1 over x plus 1 over x minus 1. But by the chain rule, we then have to multiply by the derivative of that. So the reciprocal of x plus 1 over x minus 1 is x minus 1 over x plus 1. And now we're going to do bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. So that's going to be, let's see, x minus 1 over x plus 1 times, and then we're going to get negative 1 minus 1, negative 2 over x minus 1 squared. X minus 1 and x minus 1 cancel, so we're left with negative 2 over x plus 1 times x minus 1. Or we could write it as negative 2 over x squared minus 1. So that's the derivative of that numerator. So I'm going to write negative 2 over x squared minus 1 over, and now what's the derivative of the denominator? Derivative of x to the negative 1, x to the negative 1 is going to be negative 1 over x squared. Everybody see where I'm getting this from? Okay. So now I'm just going to flip this over and multiply. So this is the limit as x goes to infinity of 2x squared over x squared minus 1. Okay, and what's that limit going to be? 2. Good. So we know that the natural log of our limit is 2. And now we just need to find what our actual limit is. So if the natural log of L is equal to 2, then that would mean that L is equal to what? Good, e squared. All right, so we just proved that this sequence converges to e squared. So we could write n plus 1 over n minus 1 to the n power converges to e squared. Now, just to get a feel for what's actually happening here, let's go ahead and evaluate the first few terms of that sequence. The first term in the sequence would have been actually undefined. There is no a sub 1. We have to start the sequence at n equals 2. So a2 would be the first term in the sequence. That's going to be 3 to the second power, so 9. And then a3 would be 4 over 2 is 2 to the third power, which would be 8. And a4 would be 5/3 to the 4th power, which is approximately 7.71. And then A5 would be 6/5 to the 5th power. 5th power. Yeah, 7.59. That's better. So you can see we went from 9 to 8 to 7.7 to 7.59, and apparently it's approaching 7.39. So this is just a side note. You don't have to do this to work the problem. I just wanted you to see that the sequence actually is. All right, another tool that you can use determine the value to which a particular sequence converges is very similar to what we saw with functions. We had a sandwich theorem for functions, and now we have a sandwich theorem for sequences as well. And that's what we're gonna do in the next video. I hope you found this video helpful. If you did, please give it a thumbs up. That will help other students to find the video. You can also subscribe to my channel, Miss Earn Mathematics, for more math videos.